TA, TV disconnection, self-test principle. Contents. 1. TA disconnection self-test principle. 2. TV disconnection self-test principle. 1. TA disconnection self-test principle. TA breakage. Current transformer secondary winding circuit disconnection. The differential protection range of differential protection between the current transformer to ensure the sensitivity of the differential protection action. The differential element with ratio breaking characteristics are very small. When the differential element on a side of the TA secondary phase or multiphase disconnection line, the differential protection will be mistaken. At present, there are set up TA disconnection self-inspection in microcomputer transformer locking components. During the operation of the transformer, once the differential TA secondary circuit disconnection occurs, the signal will be sent out immediately, and whether the locking differential protection shall be determined by the operation department. 1. Principle of TA disconnection and locking element. In an ideal situation, if the grounding short circuit of two different points inside and outside the differential protection zone is not considered, the two-phase three-phase current of TA should be equal to 0, that is, if a phase line is broken in the TA secondary circuit, then according to the above principle and whether the transformer connection group and the neutral point of the transformer are grounded, the locking judgment of TA secondary circuit break line is as follows. The epsilon 1 epsilon 2 the threshold value can be determined according to the size of the unbalanced differential current vector 3I0, 0, order current, TA quadratic value. TA three-phase currents of secondary A, B, and C, respectively. In this method of judging TA disconnection, vector 3I0 should be supplied by a dedicated zero sequence TA. At present, in the microcomputer protection device, it is often used to judge the disconnection of the TA according to the current change, the change trend and the current magnitude. When it is measured that only the current on the transformer side has changed, and the change trend is that the current changes from large to small, and the current value is less than the rated current, it is judged that the TA on the side of the current change is broken. When the current on each side of the transformer changes, and the current change trend changes from small to large, and the amplitude of the current is greater than the rated current, then the change of the current is caused by the fault. 2. Function of TA disconnection and locking element. The TA secondary circuit cannot be opened. If the TA secondary circuit is opened, a high voltage will be generated on both sides of the open circuit point, which will endanger the safety of personnel and equipment. In addition, an arc may be generated at the open circuit point, which will cause an electrical fire accident. The larger the capacity of the transformer and the larger the ratio of TA, the more serious the harm of the open circuit of the TA secondary circuit. Therefore, when the differential protection TA is opened twice, the differential protection action cuts off the transformer, which is an effective way to prevent personal harm and damage to the equipment. For a large capacity master device, due to the large transformation ratio of TA, the TA disconnection blocking element should send a signal instead of blocking the differential protection. Two. TV disconnection self-test principle. 1. TV disconnection hazard. The system voltage is used as the input measurement amount in the distance protection, which is sent into the impedance element as the measurement voltage. If the voltage mutual sensing secondary circuit fails, the impedance element will not function normally. The disconnection of the secondary circuit connected to the relay protection and the disconnection of the differential current circuit in the differential protection are also very difficult problems, And because the voltage circuit is equipped with a fuse, the disconnection and voltage loss are more likely to occur. Therefore, the disconnection of the AC voltage circuit, including the broken fuse or the trip of the small switch, must be considered in the distance protection operation. After the voltage circuit is disconnected, two situations may occur in the voltage secondary circuit. 1. Loss of pressure after disconnection. That is, after a phase is disconnected, the phase-to-phase, voltage disappears. This is the case when the three-phase circuit of the secondary circuit is disconnected or the secondary load feedback is not considered. 2. The voltage distortion of the disconnected phase-to-phase, after the disconnection. When there is secondary load feedback, the disconnected phase will obtain a certain voltage from the intact phase through the secondary load after one-phase disconnection or two-phase disconnection, but the phase and size are distorted. In either case, the impedance element will not work properly. We analyze the consequences of TV disconnection conceptually, so we mainly analyze the disconnection of one phase. 2. Behavior analysis of impedance components after disconnection and voltage loss. The so-called disconnection and voltage loss means that after the TV circuit is disconnected, the disconnected phase loses voltage, which is a single-phase disconnection voltage loss for the grounding impedance element, and a two-phase disconnection voltage loss for the interphase impedance relay. The sensed impedance of the impedance element is: when the working phase is disconnected, the sensed impedance is 0. Therefore, any impedance elements whose operating characteristics include the origin of the Rx coordinate will malfunction. Elements of this type of characteristic are full impedance, offset directional impedance elements, and the like. For the static characteristics of the directional impedance element, Zm equals 0, is in a critical action state, that is, it can move or not move. However, the directional impedance element has measures to eliminate the dead zone of action when the outlet is short-circuited, so it will act when the working phase is disconnected. If only relying on the current phase voltage memory, in the process of memory existence, the impedance element will maintain the ability to act. If there is a cross-polarization voltage, because the cross-polarization voltage phase is not disconnected, a certain polarization voltage is maintained, so the impedance element maintains the operating ability during the disconnection of the working phase. The above action capability means that the action condition should have a certain Im in addition to 0 voltage. But in fact, the minimum action current of the impedance element is very small. As long as the system circuit breaker is closed, it has this action condition. 3. TV disconnection locking method in distance protection. The impedance components in the distance protection will not work properly when the TV secondary circuit is disconnected. Some of the impedance components will malfunction when the load current flows. Therefore, the distance protection must be set with the TV disconnection blocking function to prevent power under normal operation of the system, the malfunction of the impedance relay. There are a variety of measures for disconnection blocking, and several common methods are described below. 1. Use the oscillation blocking circuit and the disconnection blocking of the impedance elements of the distance 1 and 2 sections. When the system oscillates, the distance protection composed of impedance elements that will cause malfunctions, 1 and 2 sections must be blocked by oscillation. There is no need to add TV disconnection protection. The existing analog and digital distance protection and oscillation blocking start elements are all composed of current variation elements, so there is no need to add disconnection blocking measures to the impedance elements of distance 1 and 2 sections. But there should still be a warning signal of TV disconnection, so that operators can take corresponding measures. 2. When an automatic air circuit breaker is installed in the secondary circuit of the TV, The auxiliary contact of the automatic air circuit breaker is used to disconnect the distance protection DC power supply to achieve blocking, and a disconnection warning signal is issued. 3. Use the zero sequence voltage when the TV secondary circuit is disconnected to implement disconnection blocking, and send disconnection signal. This is a simple and effective method. When one or two phases of the TV secondary circuit are disconnected, a zero sequence voltage will appear. This voltage can be used to block the malfunctioning impedance relay and issue a warning signal. Measure 3 has two major problems. 1. When a short circuit to ground occurs on the primary side of the system, a zero sequence voltage is generated, and this voltage also appears in the TV secondary circuit through the TV connected by YN/YN. The solution is to use the anti-blocking that occurs on the secondary side of the open triangle. When the primary side of the system is short-circuited to ground, although the TV shows zero sequence voltage on the secondary side, due to the output of the open triangle, if it is properly set, the false blocking can be eliminated. However, when the TV is simply disconnected for the second time, the open delta winding of the TV does not appear, so the blocking can be realized. However, it should be pointed out that this method cannot be applied to the case where the primary side of the TV is equipped with a fuse, because the fuse on the primary side is blown in one phase or two phases, and 3U0 also appears in the output of the open triangle. 2. This method cannot reflect the situation when the three-phase disconnection occurs. Because of the three-phase disconnection, no voltage will appear in the TV secondary, including the zero sequence voltage. The traditional way to eliminate this problem is to connect a resistor, in parallel with the first phase fuse, on the TV secondary side. Thank you for watching it.